On this episode of Coding 101, we're going to finish our Arduino clock.
Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for Coding 101 is provided by CacheFly at CacheFly.com.
This episode of Coding 101 is brought to you by Lynda.com, the online learning platform with over 3,000 on-demand video courses to help you strengthen your business, technology, and creative skills. For a free 10-day trial, visit lynda.com/C101. That's LYNDA.com/C101. Welcome to Coding 101. It's the Twitch show where we let you into the wonderful world of the Code Monkey and the Code Warrior. I'm Father Robert Balaser, the digital Jesuit, and joining me today is our regular special guest co-host, Mr. Lou Maresca. He's a senior software development lead for Microsoft. Lou, thank you very much for coming on to Coding 101.
Hey, thanks for having me back, and welcome coders.
Yeah, exactly. We wouldn't have the show without the coders. Now, at some point, our super special TD is going to put Lou on this back screen. But until then, Lou, there's been some interesting developments in the Java world, haven't there?
Indeed. So a lot of people, looking to start web development or application development on the web, are looking to start now, and they want to build now, and they want to build large applications, and they want to be able to build it on different platforms and devices. And that's kind of the key, is when you build on the web, you can build it for the phone or the tablet or for notebooks, and it can show up and render and be able to look the way you want it to look. And a lot of places nowadays, they teach object-oriented programming. And we talked about object-oriented programming in the past, where objects are just ways to model real-world things. Like, for example, if I wanted to model a person object, it would have like attributes like height and weight, and be able to perform functions like run or talk. And they teach languages like Swift, Objective-C, C++, Java, C#. And these are all object-oriented languages that allow app developers to like build really large-scale applications. But if you are a JavaScript developer today, you're aware that it's really tough to build large-scale applications. It's a really tough thing to do.
Yeah, hold on here, Lou, because when I think of programming languages for large-scale applications, let me be honest, JavaScript is not one of the languages that comes to mind. In fact, right. JavaScript is normally lumped in with words like disease and virus and horrible and why is this still here? Is it just a bad rap? I know that from experience, one of the things about JavaScript is that it very easily allows for really bad programming. But are you saying that we actually can safely and securely develop large-scale applications?
Right, so that's kind of where the evolution of JavaScript is coming in. So there's a new standard that's coming out. They call it what they call ECMAScript 6. ECMA is just an acronym for European Computer Manufacturers Association. But basically, they have standards that are building out, and they're actually starting to evolve JavaScript finally to be more like an object-oriented programming language. And so what that allows you to do is organize your code, create objects, perform functions, group your code into categories and namespaces and modules, create classes, build objects off those classes. So it gives you the ability to really start to isolate the code and be able to create more complex applications without kind of getting lost in the code.
All right, and now what specifically would I be looking for if I was looking for the advantages of using this ECMAScript?
So ECMAScript 6 has a bunch of new features, a bunch of new options, a bunch of new abilities. One of the biggest ones for me is the ability to just use the class ability. So being able to use classes and inheritance from class. And so like I actually have a really fast example. If you share my screen really quick here. So this is a current example of side by side. Actually, this is the original JavaScript over here, and this is the new version of it. And what I have here is I have a class that I call logo, and the class has a function that actually renders itself to the screen, and it also has a title. And this is a JavaScript. This is not the original way of doing it. And so if you look down here, I actually have another class called Twit logo. And it actually extends logo, which means it's inheriting from logo, and then I render a different logo to the screen. And so the key here is I have the ability to break apart these things, these classes, and create objects from them, which they have different functionality and they have different properties, but they can inherit from each other because some of the things are the same. And so when I actually want I can actually new it up, create a new instance of it, and then I can render it to the screen. So when I actually do that, click the button render here, boom, I get a new logo. And so this is the key. So if I actually, let's do a really quick compare side by side. This is the code over here. That's the original JavaScript. And this is creating a module, and it's trying to create a function that's called logo, and it's all the conventions, very, very verbose. And it creates confusion sometimes. And so that's where classes come in. And there's a bunch of extra features that we probably shouldn't go into because there's a lot of detail, but there's things like the new keyword called let, which allows you to scope your variables differently. There's also what they call arrow functions, where this function right here will actually turn into this really complex function over here, where it's just, actually have to build a function out and return the x by x times x and all this stuff. So this makes it a lot easier to kind of write the code and make it very, very clean and make it easier for other developers to really understand how it works.
Okay, Lou, but this is still an interpreted language, right? I mean, it's still going to run in a browser. So how does this alleviate any of the security concerns for people who have been writing in JavaScript and have been concerned about it being used for malware?
So it's not necessarily going to alleviate any of that. I mean, a lot of the times the browsers, they build their JavaScript engines to be what they call sandboxed, meaning when you render or run your JavaScript code, it runs in a specific sandbox. A lot of browsers today, like some of the newer ones, especially the new browser in Windows 10, their JavaScript, their application sandbox is very, very isolated. I mean, there's not really any way to access operating system functionality, like, calling into a Windows function to do something specific on your machine or installing an app. So these browsers are really are responsible for implementing their sandbox, and so that they don't allow things to leak out, especially through the JavaScript language. So this is not really a way to secure it more. It's more a way to add new standards to it, new abilities to it, new ways of doing things, new structures, so that it makes it easier for the coder and easier for the developer.
All right. If people did want to start poking around with this language, what are the resources that we've got for them?
So I think that one of the first ones, there's a great website out there, and we put it in the show notes. And it's basically it's on a GitHub, and it allows the ability to see which browsers have the different functionality of ECMAScript. It's what we call the compatibility table. But there's also a lot of different ways. The application I was using was called WebStorm by JetBrains. Really cool company that's out there that's creating IDEs to develop things. And they have a shareware version of it that you can check it out, jetbrains.com. Of course, they didn't pay me to say that. It's a great IDE, and check that out. You can actually start using their examples for ECMAScript 6 and basically an application framework, a compiler called TracerU that allows you to basically build out ECMAScript 6 types JavaScript. And so the example that I have, I'll actually give it to you. You can post it out there. You can check it out, and you can start playing with it. I think that's the key, is just get your hands dirty and start playing with it.
Absolutely. Start playing with it. We're going to make sure we include all that information in our show notes, so you don't have to rewatch the episode a couple of times. Just jump into our show notes, find the links, and see if maybe that's your next scripting language. Now, Lou, we are going to have to take a break here in just a moment, but before we did that, I want to tease something. The last couple of weeks, we have been speaking with Mark Smith, Smitty Halibut, the guy from DEF CON, the man who's always in the hardware hacking village. And he's been showing us some of the hardware and programming that goes into making an Arduino-powered analog thing clock. Essentially what he did was he made a steampunk clock. Now we've got a great example of steampunk. This here is a laptop that Leo ordered. It took a while to get it, but this is indicative of what you get when you start making steampunk. This is a completely custom handmade laptop case. He took the innards out of a decent laptop and he put it into this beautifully appointed wood and metal and glasswork device. Now, what Smitty had done was he worked on the electronics, on the guts of a device, but then he left off the steampunk part to you. Now, if you do want to start making stuff like this that is beautiful and yet functional, you got to stick around because we're going to give you the very last episode of our Arduino clock. But before we do that, let's go ahead and take a break and thank the sponsor for this episode of Coding 101. Now, when you think about programming, when you think about gaining knowledge in the world, you need somewhere you can go to ask questions. You need somewhere you can go to have all your maker, your DIY questions answered. And for us here at TWiT, that's lynda.com. Lynda.com is the source, the repository of all knowledge on the internet. It's for problem solvers, for the curious, for people who want to make things happen. Maybe you want to master Excel. Maybe you want to learn negotiation tactics. Maybe build a website, or maybe you want to boost your Photoshop skills. Of course, if you're a programmer and you need a reference, or if you're a new programmer and you just want to learn how different languages work, that's what lynda.com is for people like you who thirst for knowledge. Now, some of the courses that I recommend are Up and Running with Java, Design Patterns in PHP, Android Studio Essentials Training, and iOS App Development with Swift Essential Training. Big topics, hot topics in the world of programming. Now, here at the Brick House, we have made a switch from Macs with Final Cut Pro to Windows PCs with Adobe Premiere Pro. And we've been using Lynda as our reference because sometimes the functions don't translate over directly. Well, all of our editors and all of the staff here at TWiT have access to lynda.com accounts. And without that, we wouldn't have that timely reference, that place where we could search a transcript and jump directly to the answer that we need at the time that we need it. And lynda.com is all about that. Again, as a repository of knowledge, they want to give you an easy way to get to the answer that you need. With a lynda.com membership, you can watch and learn from top experts who are passionate about teaching. You can stream thousands of video courses on demand and learn on your own schedule. Now, learning at your own pace is the way to go. Their courses are structured so that you can watch them from start to finish or consume them in bit-sized pieces as you need them. You can take notes as you go and refer to them later, and you can browse each course transcript and follow along. So again, you can fast forward to those parts that you're having the most trouble with. You also can download tutorials and watch them on the go, including access on your iOS or Android device, and you can create and save playlists of courses that you want to watch. Essentially, you're creating a queue of knowledge to dump into your brain. Now, your lynda.com membership gives you unlimited access to training on hundreds of topics, all for one flat rate. Whether you're looking to become an expert, or you're passionate about a hobby, or you just want to learn something new, I want you to visit lynda.com/C101 and sign up for your free 10-day trial. That's lynda.com/C101. And we thank Lynda for their support of Coding 101. Lou, are you ready for a little bit of steampunk-inspired Arduino clock action?
Definitely looking forward to it.
Well, Jason, if you would be so kind, press the magic button. Our code warrior, Mark Smith, again, Smitty from DEF CON. In the last couple of episodes, we've shown people what Arduino is. We've shown them what the IDE looks like. We've shown them how to get input in. We've shown them how to get input out. But now we need to give them that final step, how they turn all of that into something like this. This has been our dream box the entire time. Can you show us some of the final steps?
Yeah, sure. Let's do it. So on Know-How, we showed you how to convert one of like a 15-volt panel meter into a 1 milliamp current meter. So go back and watch that episode if you haven't seen it, because it's kind of important, because otherwise, if you try to hook these 15-volt meters up to the Arduino, it's not going to, it'll only deflect.
It will do nothing. And the reason for that, again, is because by default, they're set up to measure voltage, but they do that by basically cheating.
Well, it's not so much cheating as
It's using like,
Ohm's law,
exactly.
right? Okay, Ohm's law is a fact of nature. It's important. We use it a lot. In fact, we're using it here as well.
Right, and they just drop a resistor into a meter that would normally measure current so that it will actually measure voltage. You just took that thing back out.
Took that back out.
There we go.
Well, sort of, we took it out of the meter and then we replaced it with the potentiometers on our circuit boards.
Right.
And that allows us to adjust the voltage at which we'll go to full scale.
Okay. Now show us. You've obviously hooked up 2 more meters the same way that we did in the last episode.
Yep.
And you've adjusted the potentiometers the same way we did in the last episode, so that the minimum and the max would match on both ends.
Correct.
Okay. So we've got the hardware set up, but I get a feeling that we're not done.
We're not done. We haven't done the software yet.
Oh, we gotta do the software. Okay.
Well,
Let's take a look.
Let's go take a look at the software. All right, so here is the software. It looks very similar to the software that we've been looking at in the last several episodes. We still have the voltage pins for the RTC. We ended up not using those pound defined, so I just commented them out. We have to define buttons for the minute and the hour and the calibrate. So those are the pins, the pin numbers that those buttons are hooked up to. Similarly, we are pound defining the pins that the PWM outputs are using. So those are the pins that the analog voltage will come out of the Arduino to get to. And we also have to define what the maximum scale on our PWM is for calibrate and some other things. We'll get into that in a little bit more detail. And then pin LED 13, that's something else I added in there for fun a little bit later. In our globally defined variables section, we are keeping track of the last time that we went through the loop, just like we did last time. We're keeping track of the state of the minute button and the hour buttons.
And I noticed there's a few more variables
A couple more here. So let's go ahead and talk about this now. So the way pulse width modulation works is that there is a counter that counts really fast. And it just goes between 0 and 256. And it counts all the way up and goes back down to the beginning, and counts all the way up and goes back down to the beginning, counts all the way up and goes back down to the beginning, repeatedly. And then what you do is you say, when that counter gets to a value, say 128, I want you to turn a pin on, all right? So it's counting up, and the pin is off. It gets to 128, it turns it back on, it gets all the way up to the very top, 256, and then wraps around and turns the pin back off again.
Nice.
All right, and that way you have set it up so that the pin is on for half the time and off for half the time. And if you do this fast enough, it looks like a voltage that is halfway between the maximum voltage and the minimum voltage. All right, so this is called pulse width modulation. If I instead tell it to count up to 64, then it will be off until it gets to 64 and then be on for the rest of the time, all the way up to 256. And so that will look like a 3/4 voltage.
Got it.
All right, actually, I think I've got the ons and offs backwards because smaller numbers are lower voltage, bigger numbers are higher voltage. All right, so what we do when we say analog write, what we're really doing is we're telling it at what count point should it switch the output. All right, so when it's at 0, when we give it an analog write of 0, it just never turns on. When we get it an analog write of 255, it stays on the entire time.
Right.
All right, I think there might be an edge condition in here that I'm missing, but basically in those numbers in the middle. So we have 256 ticks of our clock that we can use. 256 doesn't divide by 60 very well, so we're actually only using 240 of our ticks, which makes use of most of our analog voltage and gives us 4 ticks per second or per minute or per whatever, right?
Which is why you had to use the onboard crystal in the last episode, because you need something that's actually going to count down to that. And
Exactly.
The RTC can't do that.
The RTC only gives me 1 second resolution, and I want 1/4 second resolution. And so, let's go back to the code. That's what the millis at the top of the second is there. So the Arduino has a function called millis, which says how many milliseconds have I been powered on.
Right.
And it's a counter that just goes up from 0 as it's on. It just counts up the number of milliseconds since it's been on. And so if I take what that value is when we transition from 1 second to the next, then I can count up 250 milliseconds, that's 1/4 of a second. Another 250 milliseconds, that's another 1/4 of a second, and so on. And then I only do that 3 times, and then I look for the second, for the real-time clock to update to the next second. So we're not actually drifting out of order.
Now, a quick note here is we're using PWM to be able to drive a particular amount of current into the meters.
Sort of.
Sort of, right.
So we're actually outputting of an average voltage, and then that voltage goes through a resistor to the current meter, just like it was doing before, except that we're putting our own value of resistor in there,
the potentiometer.
the potentiometer, so that we can fine-tunely adjust at what voltage the output of the Arduino makes full scale on the meter.
Fantastic.
Okay? That's why it's an adjustable
That's why
resistor.
it works.
Because these are 1 milliamp meters, but I think this one's like 2.5, or maybe it's a half of 1, but it's off a little bit. So every meter is different. So I don't want to just put a fixed value there because it will change based on how much current that particular meter needs.
Because I'm sure there are people who are out there who are, wait a minute, you removed a resistor and you added a resistor? I don't understand why you just did that.
Because I wanted to change the value of that resistor.
Yeah. Another note about PWM is we're using it for this application. So we're pushing it into the meters, but PWM can actually be used as a communications bus. I mean, there are applications that will read the on and off states on the other side, so you can have one device talking to another device via PWM. That happens all the time in quadcopters.
For servos, specifically, yes. So servos use that a lot. Most other things use serial buses.
Yeah, it's more accurate that way.
Yeah, you can get a lot more control. But if the servo, what you're trying to do is get to about this value, and so it's still kind of an analog value that you're trying to send. And so pulse width modulation is a way of taking what is otherwise a digital output. It's either on or it's off, and then kind of faking an analog value by turning it on and off really fast, and taking the average of those two voltages.
But back to the code.
Back to the code. All right, so that's what the millis at the top of the second is. So we're trying to count milliseconds so that I can have these 4 ticks per second. And then last ticks is another state variable that we use. Setup is very much the same. We are setting up our ins and outs just like we did before.
We've seen all of this before.
We saw all this last week, so I'm going to fly right past it. Initializing our globally scoped variables. You never want to use a variable uninitialized. Bad things happen. So let's go into our loop. Just like before, we're doing an RTC.get. We're getting the time. We're breaking it up into time elements, just like we did before. We're checking to make sure we didn't get any read errors from our RTC. Then we have a section here for calibrate. We talked about this last time,
right?
Without going into too much detail on what exactly we were calibrating or why. But
essentially, if you hit the button, it's going to give it a low state. It will go into this if statement, which will allow you to set the max on the meters so that you can adjust with the potentiometer.
Adjust the potentiometers to read full scale. Exactly. So, and then out of that, we're down to the time setting, which is what we looked at last time as well. These have not changed at all. And then see if the time has changed and print it if it has. So if this time is different than last time, the only thing we've changed here is that we've added this millis at top of second. So I want to see what the value of the millis value is from the Arduino when the second changes. When it changes from 1 second to the next, because I want to reset my count of 250 milliseconds, 500 milliseconds, 750 milliseconds, and so on. So I'm taking what the millis is at the top of the second, all right? And then here's our debug output, just like before. And then set the analog outputs. This is the fun part. So set the analog outputs. The PWMs are 8-bit, so this is the part that I just described. PWMs are 8-bit, 0 to 255, but time is 60-second increments, 60-minute increments. So we're going to use 4 ticks per second or minute, and that will get us between 0 and 239, right? And it uses most of the PWM's bandwidth and still allows us to have a relatively smooth movement. If you didn't care about any of this and you wanted your meters to tick 1 second, you could go ahead and do that and remove all of this and just have it output the value. But the problem is that the meters, when they move too quickly, they kind of swing around a whole bunch, right? And so by having it move smoothly, it can move very smoothly. But if you have it go from here and then 1 second there, it doesn't just go like this. It goes whir, 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 and it's very hard to read. So having a nice smooth movement across, it's much easier to read.
Okay.
So that's why we do it this way. Go back to the code, please. And we have, so what we want to do is we want to try and calculate how many ticks it has been since the top of the second, all right? So we're going to go ahead and the current millis minus the millis at the top of the second. So that will give us the number of milliseconds that have elapsed since we are in this second, and we divide it by 250.
Right.
And that will give us how many quarter-second ticks it's been since the top of the second. If that value has changed since the last time we went through the loop, then we're going to go ahead and update it so we know, so that we don't just go through this if statement over and over again. And then we will set the analog output values. So I mentioned earlier we had an LED. There's actually an LED on the Arduino board on pin 13, and what I have it set doing right now is just tick-tocking.
Right.
So if the seconds ends in a 0, it will go to a low value. If it ends in a 1, it'll go to a high value. So it just turns on for a second, off for a second, on for a second, off for a second. That's just kind of another output that you can get that was easy to do in a single line. So I went ahead and did it. But we're going to set the analog value for the seconds hand. So we're going to take this TM, which is the time elements. We're going to take the seconds out of there. We're going to multiply it by 4 because there are 4 ticks per second.
Right.
And then we're going to add the number of ticks since the last second.
Right.
The
So this
number
is
of
basically ticks is equal to ticks plus the change.
Yes. So it's ticks are quarters of a second.
Yes.
Right. And so we're calculating how many quarters of a second do we want to display on the meter, and then we just analog write that value to that PWM output on the meter.
Fantastic.
And that's it. And then we go down and do the same thing for minutes. 4 ticks per minute plus 1 tick for every 15 seconds. All right? So ticks equals minutes times 4 plus TM seconds divided by 15, which is, this is integer division, so every 15 seconds you'll get another one. All right? And that allows the minutes to do a very smooth movement as well. Similarly for the hours. This one's a little bit more complex because the time, the data structure represents it in 24-hour time, but I want to do a 12-hour clock because I'm not military. I'm not one of those nerds that likes 24-hour time. I like 12-hour time. So I want to take the 0 through 23, modulo 12, so it goes 0 to 12, 0 to 12. All right, do your viewers know what modulo?
Oh, yeah.
We've talked about modulo?
That, yeah.
Okay,
C
good.
sharp.
So, so we're doing a modulo 12, and then we are multiplying it by 20 because there are 20 ticks per hour. There are 12 hours in full
right.
scale.
That makes
240 divided by 12 is 20. So there are 20 ticks per hour. And then it is 1 additional tick for every 3 minutes because we want to take the 60 minutes of the previous one and divide it by 20 because we want to know how many of those, how many minutes per tick between the hours. See, it gets a little bit complex.
This is just math, folks.
It's just math.
This is going to be in the show notes. Don't worry about it. Don't freak out.
But it's all in the comments.
Exactly. It's in the comments. And what I like about it, if you go to the screen, you've actually seen code like this. This is the same thing as writing to screen. No matter what language we covered, there's always some sort of function that lets us write out to screen. The only difference here is that instead of writing out to the screen, we're writing out to a pin.
To an analog voltage on the pin.
Which is connected to a physical device. So
yeah.
The math is the math, and you can freak out if you want, but it will be in the show notes. Otherwise, this is actually quite simple.
Very simple. And so you got a little bit of math. We just, take the hours, divide it, or modulo 12 to make it a 12-hour clock, multiply it by 20 for 20 ticks per hour, and then 1 additional tick for every 3 minutes. And that ends up being a very smooth time movement for the hours.
That gives us our clock. And what I would suggest is that they go ahead and write this in a simpler way and just let it tick up per minute.
Sure.
See what the meters do, and you'll find out why he did it this way.
Yeah.
Because he likes the smooth motion so that the meter's not constantly bouncing up and back and forth.
Correct.
All right. Now, if they're going to start to do this, they're also going to have to think about a project box. We're not going to cover that here.
Nope.
We might cover that in Know How at some point in the near future.
The other thing we're not going to cover is the artwork on the panels, because these are reading 0 to 15 volts, right? You actually want them to read hours, minutes, and seconds like they are over here.
Right. So you're going to have to do that on your own, figure out a YouTube way. We're going to show you the hardware and the software that you would need to make something like this. But Smitty, this is fantastic. Oh, obviously, I asked you to create something with Arduino, something with an embedded processor that would leave us with a project that they could do. I think you've done that. But let me ask you this. Let's say they get through this and they say, wow, this is nice. I like this. I like being able to program something that has an effect in the real world like this. What resources would you suggest for our audience? What would you tell them to try next?
Again, that's one of those things that I would have a hard time saying because I don't know what they need in their life.
Yes.
Right? So the project that works best for you is the project that you will be motivated to do. So find something in your life that you want to make, whether it's something crazy stupid like an analog panel meter clock that's cool, but doesn't really serve a real function. You can buy a clock for a hell of a lot less money than you'll spend on all of these parts, right? But this is just a fun project to do. Either something like this or something functional where I need I think my refrigerator is failing. And so I want to put my refrigerator on the internet so that I can measure the temperature inside my refrigerator and graph it over time or something like that, right? Find something in your life that you want to do that you think something like this could do for you. Those are the best projects to do. If you are thinking of learning a new technology, be it Arduino or a new programming language or anything else, I personally have a very hard time trying to learn something new if I'm doing it just academically, if I'm not doing it practically. The far easier way for me to learn something is to have a project, have a goal in mind. All right, I need to accomplish this, whatever this is. And I want to, at the same time, learn a new programming language or learn how to use Arduinos or whatever. And so rather than just saying, oh, I'm going to go through this coursework that has these exercises on how to learn Python or how to learn C for an Arduino or whatever it is, that they give you some code that might teach you the subject matter but don't really do anything useful, that doesn't sink into me. Whereas if I say, I've got a goal, I've got a thing I need to build, let me learn the bits and pieces I need to do that, that sinks in a heck of a lot better than just the random exercises.
You know, just listening to you, there's one project that I've been wanting to do for a while, and that's the Arduino controlled blinds. And actually, it's a fantastic analog because we've got switches and we know how to deal with switches and take that input. That I could replace that with a photocell. So whether or not the photocell is getting lit or not.
Absolutely.
And then the output is very easy to connect to a relay that will connect a motor either on a high or a low condition. When there's light, open up the motor that lets it open the shade or close the shades. When there's not, reverse that.
Oh, I was going to go even better and say have like vertical blinds or Venetian blinds and use a servo.
To adjust.
Yes.
Yeah, I mean, the possibilities really are limitless. And now that you've seen a very good example of taking inputs and pushing outputs, the sky is the limit.
Sky's the limit.
Mark, thank you very much for doing this project.
Absolutely. Thanks for having me on.
This is so much fun. We're going to have you back at some point.
Cool.
Now, I don't know if I can ask you about the fish tank. Can you bring the fish tank at some point?
I don't think I can bring it. It's awfully heavy.
Oh, okay.
55 gallons is a lot of water. But we can talk about it, and I can show you some of the technology that I used, and I can probably take some videos at home so you can watch the sunset and sunrise that my fish had.
Or we could just buy a fish tank.
Or we could just buy a fish tank and put one here. Yeah, we could do that.
Could you please tell the folks at home where they can find you? Because this is a lot of work, and I really appreciate it. I want them to be able to follow you and see what you've been putting together.
Okay. Well, I usually tweet about my projects and escapades as @SmittyHalibut on Twitter. I don't really have a whole lot to plug like a lot of guests on the Twit Network do, but you can find me on Twitter @SmittyHalibut. Yeah. I'm there. I'm always happy to talk with people, answer questions. Show me your cool stuff. If you have been inspired by this series to make something, be it a clock or whatever it is, please tweet me and let me know what it is you've done. I would love to see it, and I would love to see how excited you are and the cool stuff that you have built. Even if you don't think it's cool, if you think, oh, well, it's just this little tiny thing, whatever, I don't care. If you made it, it's awesome. That's what I want to see. Please show me.
Yeah. And one last note, I'm going to say this, he doesn't know I'm going to say this yet. He is a fan of both Ham Nation and Steve Gibson. So, hey, coders out there, if you could throw a note to both of those shows, to Steve Gibson and to the folks of Ham Nation,
Bob Heil,
and tell them, you know what, you need Smitty on the show. I'd be fantastic. I mean, I'd love to see him speaking with Steve Gibson. I'd love to see him as one of the guests on Ham Nation.
KR6ZY 73s.
There you go. Until the next time we've got an Arduino-powered unit, that's been Mark Smith.
That's been Father Robert Balazer.
Yeah. And now we go back to me.
You. It's kind of awkward.
Yeah. That project was a lot of fun, and I've already repurposed a lot of that hardware. I'm not sure if I told you about this. I talked about this on Know How. I hooked up the same 3 leads to the tricolor leads on one of those strips of LEDs. And it just changes the color of the clock throughout the day. It's very, very fun. I mean, once you actually understand how the hardware works and how the software integrates with the hardware, really the sky's the limit. Lou, have you done any work with Arduino?
Yeah, I've done a couple things actually, a couple projects with around detection and infrared sensors.
Yeah, we've got M5 in the chat who's asking if you could recreate one of those TIX clocks. Now, you couldn't do it directly by connecting one input to every LED, but you could use a combination of relays with different pins in order to achieve the same effect. There's too many lights that have to light up to properly make a TIX clock. We're definitely going to do more of these crossovers. And speaking of crossovers, if you're watching these episodes of Coding 101 with the Arduino clock, that's the last 4 episodes, you're also going to want to watch the last episode of Coding 101 and the next 3 episodes of Coding 101 because we go further into the hardware on that show. This is supposed to be a crossover, so if you're watching one show, make sure you watch the other show so you get the entire picture. Now, Lou, do you want to leave the audience with any parting shots about you, about what you do? You're here, our code warrior, and now you're our guest host, and I really love having you on. I want people to know more about where they can find your work.
Yeah, thanks, Padre. Yeah, so I've been at Microsoft for 11 years as a programmer, and most of my work that I do there is found at crm.dynamics.com. But you can always contact me at LouMM at Twitter. And of course, also I have my email too, loumm@outlook.com. Feel free to do that. I am sending you my email because I am so confident that the new tools that we have on there are going to be able to filter it out for me. So send me an email.
That's a challenge, chat room. Get out there and send email to Lou. Now, don't forget, we're also going to include all of his links in our show notes. And speaking of the show notes, if you had any questions about what we've been doing with this Arduino clock, or if you want to check out the code, because we do give you the code in its entirety, make sure to go to our show page at twit.tv/code or Coding 101. They all go to the same place. There you'll be able to find all of our episodes. So if you want to download back episodes, if you want to get an entire run of a module, for example, if you want to see what we did with PHP or with Perl or with C#, or if you want to see the Arduino clock, you can go ahead and download those episodes to have them on your device of choice and watch them at your leisure. That's also where you're going to find the show notes. Like we said, the links from Lou or the code base from Smitty. It's just a really place to go if you want to go further into coding. Don't forget, we also have a Google Plus group. It's over almost 2,000 members strong. Just go to G+ and look for Coding 101. It's a great place to ask questions or to give answers to people who are new to coding, but it's also a good place to suggest guests. We've actually got 3 or 4 guests who came directly from the G+ community. And if you want your input, if you want to push the show in the direction that you're most interested, that's the place to do it. Also, don't forget that you can find me on Twitter at twitter.com/PadreSJ. That's at PadreSJ. If you follow me, you'll find out what we're doing each week for Coding 101. I always announce our topics and our guests, and you'll also see what I do in between shows, be it for Know How, which I do on Thursdays, or Padre's Corners, Try It, and Before You Buy on Fridays. Also, if you are watching this on the download and you're wondering why you didn't see us on Thursday, we have changed our hours. Coding 101 is now at 2:30 p.m. Pacific time every Monday. We're going to try to do as many live shows as we can. We may be doing a bunch of pre-records just because the format of the show is slightly shifting, but make sure you drop by when we are live. Now, speaking of live, as long as you're going to watch live, why not jump into the chat room at irc.twit.tv? It's a great place for you to ask me questions during the show, but also it's a nice way to be part of the experiment that is Twit TV. Until next time, I'm Father Robert Balacer, the Digital Jesuit. This has been Coding 101. End of line.